So one of those problems was that you know that there are 66 total handshakes among people in a room, and you know that everybody shakes everybody else's hand. So the question was, how many people are in the room? I thought this was a good example because my friend and I took somewhat different approaches. The one he did is up here, where he drew a bunch of little stick people and then just tried to sort of, so this is an example of sort of simplification, where instead of trying to solve the problem, you say, well, what if I have 3 people? How many handshakes do I get? So you say, you know, like these two, and these two. So if I have 4, I get these two, these two, these two, these two, these two, these two. And so he just started small and just looked for the pattern. So a lot of this kind of very mathy stuff is trying to find patterns. And pure math people tend to be people who are very, very good at seeing patterns. The way I thought about it was more by analogy. So I come from, well, among many backgrounds, a computer science background, and so I know a lot of graph theory, and I like to represent problems as graph problems. So what I did was think of this problem where, so this is for 5, and then, so this is a graph where the circles are vertices, and then you have edges that go between. So let's see if I can manage to draw all the links. So what I've thought of is the people in the room as a graph with certain connections that are the handshakes. So this is the sort of representation problem where we're taking a physical thing and recasting it as sort of a mathematical object. So that's the come up with a plan, and then the, you know, executing the plan is actually proving that it's true. You know, in this case, you know, for 66 and 12, 12 is the answer, by the way.